In this section, we're going to look at the Cartesian coordinate system and then go right into graphing linear equations in two different ways. This is the Cartesian coordinate grid. We use the Cartesian coordinate system to actually plot points. Each one of the points I have here as examples is labeled with an x-coordinate first and a y-coordinate second. The x number will tell you the horizontal change, the y number will tell you the vertical change. So let's just go ahead and look at these different points plotted on the grid. So first, point A. I'm going to start at the origin and then take it 3 units to the right and 1 unit up. So there's A. If you like, you can label the points just to keep track of where they're at. And next, point B, -2, 4. In this one, I'm going to go to the left 2 units at x equals -2, and then up 4 units. There's B. Point C, -4, -3. Point D has an x-coordinate of 5 and a y-coordinate of -2. Point E, 1, 3. X equals 1, y equals 3. And finally, point F, this is 0, 0. We call this the origin because it's right in the middle. You don't go to the right or left any or up or down. Now, each one of these points, they're all falling on different parts of the axes. This is the coordinate grid system where each quadrant is labeled. We call this first quadrant, quadrant 1, then moving counterclockwise, quadrant 2, quadrant 3, and quadrant 4. Let's go ahead and take a look at our very first line. Most lines are given in this form. This is in standard form. I'm going to go ahead and rearrange it so that y is by itself and actually use a table of values to graph it. Well, if I want to get y by itself, I'll need to move the negative x to the other side. So I'll add it to the right. Now it's written in a form that'll be easier for me to produce a table. When making your table, you can plug in any x values that you want. We just want to get a good idea about what the line looks like. So at least we'll do 3 points. I usually choose some easy ones, like 0, for instance. If that's the case, 0 plus 3 equals 3. This corresponds to the dot 0, 3. Another point, we could use x equals 1. 1 plus 3 is 4. So there's another dot at 1, 4. You can even use negative values, like -2, for instance. -2 plus 3 is 1. -2, 1 is right here. Once you have at least 3 dots, that'll be enough to draw the line. I'll use arrows at other end just to show that it goes on infinitely in both directions. This method is just called using a table of values. It requires y to be by itself. That's the only flaw. We're going to do the same thing, but this time I'm going to use a different technique. I'm going to use the intercepts. Intercepts are places where it crosses the x or y axis. When doing this, you only need to have 2 points. One place where it crosses the x and the other place where it crosses the y. So let me go ahead and do the x-intercept. If it's crossing the x-axis, y must equal 0. So I'm going to write the equation, substituting y equals 0 in. The only unknown is now the letter x. 3 times 0 is 0. So I find that the x-intercept must be 3. There's a point, 3, 0 on this grid. For the y-intercept, I'm going to do the exact opposite. I'm going to make x equals 0. So now 2 times 0 minus 3 times y equals 6. Y must be negative 2. So I have the point 0, comma, negative 2. These are really special points. They show you exactly where it crosses. I can connect the dots now to graph my line. In your assignment on WebAssign, you're allowed to choose either method. So whatever you prefer. Just remember, if you want to do a table of values, you'll need to solve for y first. Try this one yourself using the intercepts method. Would give me 2. Negative 2 would give me negative 4. This should be enough. And there's my line. It only crossed once at the origin. So it's a little bit different, and your intercepts method might not be the best to choose. The last one is the most unique problem. Let me go back to the table method again for this one, just because of its uniqueness. They all lie in a line. Y equals 3 produces a horizontal line at y equals 3. And that's no coincidence. That will always happen. Anytime you have a plain y equals, it will produce a horizontal line.